Okay, so kita dah gunakan integer 10. Okay, integer 10 digunakan untuk you toggle, okay, you toggle anything related to the display lah. Alright, and one of the function you can use that you can draw also a line. Okay, first kita nak tengok kat sini, write a program to clear the screen. Okay, set the mode CGA of 640 times 200 resolution and draw a horizontal line starting at column 100, row 50, ending at column 200, row 50. So maksud dia line lah. Okay, sebab you punya column yang berubah. Okay, so column from 100 to 200. Okay, so column akan bergerak daripada 100 to 200. So akan ada horizontal line. So you punya row dekat 50. Okay. Alright, so kita letak komen move AX as 06. Okay, 00. Okay, untuk scroll the screen. So macam biasa, move BH 07 for normal attribute. Okay, and then move CX. Okay, 0000. Okay, so yang ni sebab dia nak clear the screen. Okay, so the first four tu macam sebelum ni that we discuss. So untuk clear the screen, so move CX00 and move DX184F. Okay, sehingga habislah. Alright, from 00 sehingga the last row and column, okay, for the screen. Okay, and then invoke the interrupt 10. Okay, untuk clear the screen. Okay, now dah settle. Okay, kita nak set yang B pula. Okay, set the mode to CGA of 640 times 200 resolution. Okay, and then set mode AH00. Okay, and CGA sebab 640 times 200 is high resolution. So kita pilih mode 06. Okay, so kita state that into AL. So move AL 06 and then integer 10H. Sorry, interrupt 10H. Okay, so dah ada dua interrupt. So dah settle. So dua part kita dah clear the screen and so set the resolution mode. Okay, and then the last one, right, we want to draw a horizontal line. So kita kena choose lah. Alright, first kena choose the column. Okay, choose the column at 100. So move CX 100 and row 50. Okay, and row 50. Okay, and then after that, so sebab dia nak move kan, so dia nak move, so you kena buat loop lah. Alright, so you kena buat loop. So AH, okay, 0C, okay, untuk draw a line. Okay, and then move AL 01. Okay, so dia punya pixel akan jadi white lah. Okay, line tu akan jadi white. Okay, interrupt 10H, invoke interrupt to draw the line. Okay, so itu command untuk draw the line. Tapi itu untuk dekat 100 lah. 100 and row 50. So you tak nampak lah, dia punya tu akan ada satu je, very small line. Okay, tapi dia punya soalan dia nak daripada 100 to 200. So dia kena move lah from 100 to 200. Okay, so untuk move, so you kena buat loop. So you kena increment the CX. So CX ni akan jadi 101. Okay, 101. And then compare. If CX tak sampai 200, so dia akan loop lagi. So dia akan buat lah, draw. Okay, so dari situ you akan nampak, okay, one horizontal line until line 200. Sebab bila line 200, dia jumpa jump not zero. So maksudnya sekarang bila dia compare, dia dah jadi zero lah. Okay, dia dah jadi zero. Right? Dia dah jadi zero. Bila jadi 0, dia akan exit the loop. Okay. So dia akan stop dekat situ. Okay, so we finish with the interrupt 10. Okay, we move further. So we have interrupt 21. Okay, in previous chapter, a fixed set of data was defined in the data segment and results viewed in a memory dump. Okay, so this section uses information inputted from the keyboard and displayed on the screen. Okay, so a much more dynamic way of processing information. Okay, so sekarang ni dia punya bergantung kepada keyboard. Tadi kita dah siap tu dia punya code. Okay, kita dah type, kita tak perlukan input. Okay, so maksudnya bila kita on to the screen, so bila that program is running, so it already show what is actually already been done. Okay, so kalau interrupt 21 ni, kita nak request something, okay, from outside, so kita kena type, okay, daripada keyboard baru dia react, okay, on the screen. Okay, so when the OS is loaded, interrupt 21 can be invoked to perform some extremely useful function. Okay, commonly referred to as DOS interrupt 21, okay, function call, in contrast to BIOS ROM based interrupt 10. Okay, so dia compatible dengan interrupt 10. Okay, so apa interrupt 21 ni buat? Interrupt 21 can send a set of ASCII data to the monitor. Okay, set AH09 and DX, okay, equals to offset address of the ASCII data. Okay, displays the ASCII data string pointed at by DX until it encounters the $sign. Okay, so bila you set, you request nak send the ASCII data tu, you pun tulis lah, you type whatever on your keyboard, but you must remember that you must put a $sign at the end. Okay, okay, so macam contoh ni, the data segment and code segment to display the message, the earth is one but one country. Okay, so ni you initialize data, ASC, okay, DB, okay, define byte, okay, the earth is but one country, okay, and then you put the $sign, okay, in the end. Okay, so kalau you tak put the $sign at the end, so dia akan baca lagi lah the next, okay, whatever you put after that, dia akan baca lagi. Okay, so after that you buat move AH09, okay, untuk display the string of data, okay, and then move offset data as key yang tadi tu, the earth is but one country, okay, offset into DX, okay, and then interrupt 21. Okay, so to output only a single character 02 is put in AH and DL is loaded with the character to be displayed. Okay, so the following displays the letter J. Okay, ini kalau you nak display hanya satu character. Okay, tadi is a words, okay, words, okay, couple of words. Ini kalau nak display satu satu character, okay, so dipakai cara ni lah, move AH02, okay, and then move okay, DLJ, okay, DL holds the characters to be displayed, okay, and interrupt 21. Okay, this option can also be used to display $sign on the monitor as the string display option, okay, 09 will not display $sign. Okay, so this function waits until a character is input from the keyboard, then echoes it to the monitor. Okay, after the interrupt, the input character will be in AL. Okay, so contoh dia, move 01 to AH, okay, Okay, move option 1 inputs 1 character, okay, and then interrupt 21. Okay, after the interrupt, AL tu akan jadi ni lah, the input character in terms of ASCII tu, apa yang you input. So akan masuk dekat register AL. Okay, so program 4.1 combines interrupt 10 and interrupt 21. Okay, so macam kita tengok contoh tadi, dia ada interrupt 10 and interrupt 21. So combine lah. So interrupt 10 tadi berkaitan dengan display. So interrupt 21 dia requires input from the keyboard. Okay, so sebagai contoh, so initialize dia. This is a test of the display routine. Okay, so dia ini message yang akan keluar. Okay, and then macam biasa kena letak dia $sign there. Okay, main procedure. Okay, for move AX, okay, data. Okay, data dekat sini, and then move AX into DS. All clear, okay, untuk clear the screen. So dia punya ni function ni ada actually dekat bawah of this program lah. Okay, and then core cursor untuk set the cursor position, okay, core display, okay, untuk display the ni lah, cursor untuk display the message, okay, and then move for C, AH and interrupt 21 ni untuk terminate the program. Okay, contoh ni tak nampak dekat sini. Okay, I will give you the full the full, it should be on the textbook. If you have the textbook, you can refer to the textbook. I will share the the text, the PDF text to you. Just remind me later in the WhatsApp group, okay, so you can refer to that example. Okay, so we will look into, tadi kita dah ada beberapa option lah, okay, so tadi 0C, okay, now 0A, okay, 0A digunakan untuk input a data string from the keyboard, okay, a means by which one can get keyboard data from and store it in a predefined data segment memory area. Okay, so you set 0A ni, you masuk dalam register AH. Okay, and then DX, okay, is equals to offset address at which the string of data is stored. Okay, so it is commonly referred to as a buffer area. Okay, so DX when you equals to the offset address, so ini dipanggil as a buffer area. Okay, so DOS requires a buffer area to be defined in the data segment. Okay, the first byte specifies the size of the buffer. Okay, and then the second, the number of characters from the second byte specifies the number of characters, okay, from the keyboard. Okay, and in the third byte, okay, the key in data placed in the buffer. Okay, so sebagai contoh, this program accepts up to 6 characters, okay, from the keyboard, okay, including return, okay, carriage return key, okay. 6 buffer locations were reserved and filled with FF. Okay, so you tengok kat sini. Okay, first byte. Okay, 6 question mark. Okay, 6 TUP. Okay, so dia akan duplicate lah. Duplicate FF ni. Okay, 0010. Okay, 6. Okay, so dia akan dia akan dia akan repeat. Okay, dia akan repeat 6 kali. Okay, so daripada 0012, okay, to 0017. Okay, so semua akan diletak dengan FF. Okay, and then move 0A. Okay, so apa kegunaan tadi? 0A untuk input a data string, okay, from the keyboard. Okay, and then load offset address of the buffer. Okay, so you kena load the offset address of the buffer. Okay, so offset address ni dekat dia is data 1. So kita panggil dia dari sini lah. Alright, data 1 ni. Okay, move into DX. Okay, invoke interrupt 21. Okay, so apa akan berlaku? Okay, apa berlaku? So you tengok dekat memory content dia akan jadi macam ni. Okay, so memory content dia, okay, memory content of offset 0010. Okay, 0010 dekat sini. Okay, dia akan jadi 06. Okay, 06. And 0011 tak ada. Okay, dia akan jadi 000. 00. And then kat sini ada 6. 2, 1, 2, 3, 4, 5, 6, 7. Okay, ada 6 kat sini. Semua akan fill dengan FF, 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 and FF. Okay, so you kena tahulah how to how to get this kind of memory content. Okay, alright. Okay, the PC won't exit interrupt 21 until it encounters a return. Okay, assuming the data entered through the keyboard was USA return. Okay, the content of the memory location starting at offset 0010 would like this. Okay, so maksudnya ini data yang di fill in. Okay, data yang di fill in. Okay, so dia akan di reset macam ni lah. Okay, USA. Okay, USA return. Okay, so kat sini akan jadi U. Okay, 55 ni akan jadi U. Okay, 53 S. Okay, 41 is A. Okay, 0D is return. Okay, or carry. Okay, carriage return. Okay, carry return. Carriage return. So dia akan jadi macam ni. Okay, so ini bila dah di fill in. Okay, you tengok perubahan dekat sini. Apa yang berlaku is, okay, kat sini 0011, okay, akan jadi 03. Okay, dia akan jadi 03. So depends on the number of data key in lah. Okay, number of data key in. So ada 3 USA, so dia akan berubah menjadi 3. Okay, so this is what I mentioned, right? So those are the size of buffer here. Okay, the size of buffer, so you can specify. So 00110 ni, so depends on the size of buffer dekat sini. Okay, so kalau you punya buffer ada 7, 8, 9, you kena ubah lah. Okay, so dia akan berubah dekat sini. Okay, and then 03 tu depends on the input, that how many inputs that you put from your keyboard. Okay, kat sini ada USA ada 3, so 3 lah, right? Okay, so ni macam saya cakap tadi, so 55 tu untuk letter U, 53 untuk letter S, and 41 untuk letter A. Okay, so you refer balik pada ASCII table, so you will find out, right? Alright, okay, and then the yang number 4 tu, dia ni lah you punya carriage return tadi. So bila you press the carriage return, so dia akan change, okay, you punya value dekat after A tu, okay, 014 akan jadi, 0015 akan jadi 0D. Okay. Alright. Okay, apa jadi if yalah, you set tadi buffer 6. Alright. Buffer 6. Tapi you letak jadi lebih. Alright, sebab bila buffer 6, you kena kira consider dengan carriage return sekali lah. So, bila you punya buffer 6, dia akan membuatkan you punya komputer akan sound the speaker. Okay. Okay, entering more than 6 characters, 5, okay, plus the CR, okay, carriage, ada 6. Tapi kalau you lebih, okay, the computer akan sound the speaker. Okay. So dekat sini, the contents of the buffer will look like this. Okay. So kalau dia ada 5 plus ni plus carriage. Okay. So benda ni akan jadi 5 sebab dia depends on 5 karakter tu lah. Okay. Okay. USA maksudnya you buat space. USA space, you tekan space bar. Okay. Ada jarak USA space and you tak A. And then baru you enter. Okay, so dia akan makan. Dia akan makan ke semua 6 buffer tadi. Alright. So location tadi, okay, macam saya cakap, okay, ini di reserve untuk space. Okay. And then 0016 untuk A. And then 0017 untuk OD, which is for the return lah. Okay, carriage return. Okay. The actual length, okay, is 05 at the memory offset. Okay, ni actual line dia. Okay, memory offset of 0011. Okay. Okay, if only the carriage return key is activated and no other character, okay, 0A is placed in memory, okay, 0020, okay, 0021 is for the count, okay, and then 0022, okay, is the first location to have data, okay, that was entered. Okay. So dekat sini dia kata kalau carriage return je activated and then you tak put any other character, okay, apa jadi? Okay, so you nak ada dekat sini data 4 defined by 10, okay, duplicate, okay, FFF. So maksudnya you ada 10 lah yang FF di duplicate-nya. Okay. Right, so kat sini ada 10, okay. So FF, okay, FFFFF, okay, FFFFF. Okay. So dia berlaku kat sini. Alright. So dia akan state, buffer akan state, okay, 10. Okay, still akan state 10 sebab you ada 10 dekat sini. Alright, 0A lah. Okay, kalau 10 tu dalam 0A. Okay, sebab A kan 10. Okay. And then you punya dekat sini 0021 ni, okay, 0021 akan jadi 0 sebab you tak type apa-apa. You just press enter key je. Tapi dekat first buffer area ni dia akan bertukar kepada 0D. Okay. Dia akan bertukar kepada 0D sebab you press the enter key tadi. Okay, so itu je yang berubah. Okay, if only the return key is activated, okay, 0022 has 0D. Okay, the hex code for the range return. Okay, the actual number of characters entered is 0 at location 0021. Okay. Okay, you can see many more example, okay, in the book. Okay, which if you don't have the book, okay, so I will share after, okay, after this class, alright. Okay, the PDF copy of that. Okay, kita tengok next kepada option 07. Okay, tadi 0A, okay, 0C. So kita tengok now 07. Okay, 07 requires the user to enter a single character which is not displayed or echoed on the screen. Okay, so dia tak muncul dekat ni lah screen. Okay, the PC waits until a single character is entered and provides the character in AL. Okay, so sekarang ni okay, you define AH07, okay, keyboard input without echo. Okay, maksudnya dia tak display. A interrupt 21. Okay, so ini, alright, ini just untuk ni lah. Okay, dia ada, there may be some example after this, alright. So regarding you nak apa ni, you want to, you tak nak apa ni, you tak nak display something that you key in, okay, in the key on the keyboard, okay. Macam you nak enter your password, right? For example, you don't want it to be displayed, okay, on the screen, okay. So you type in the keyboard, dia akan save terus dalam AL. Okay, so itu function AH apa ni, untuk interrupt 21 option 07. Okay. Okay, kita boleh juga gunakan label untuk define the string buffer. Okay, the label directive can be used in the data segment to assign multiple names to the data. Okay, so contoh dia macam ni lah. Okay, name, label, attribute, okay, used to assign the same offset address, okay, to two names. Okay, the attribute can be byte, okay, word, double word, okay, forward, okay, quad word, okay, and terabyte. Okay, in the following, okay, dekat sini Joe dengan Tom. Okay, so dikata kat sini the offset address assigned to Joe is the same offset address for Tom. Okay, since the label directive does not occupy any memory space. Okay, so offset address untuk Joe dengan Tom akan jadi sama. Okay, so use this directive to define a buffer area for the string keyboard input. Okay, so ini cara dia. Okay, let's say you nak labelkan something, okay, data buffer apa dia, and label, okay, and then byte. Okay, maximum size 10, you set 10, buffer count you tak specify, okay, and then buffer area you kena ada 10, okay, duplicate. Okay, in the code segment, the data can be accessed by the name as follows. Okay, so macam biasa you kena initialize AH0A, okay, untuk load string into buffer, okay, and then move the X, okay, offset data buffer, Okay, data buff yang ni lah, yang ambil tadi. Okay, and then interrupt 21. Okay, move CL buff count. Okay, load the actual length of string. Okay, so sepatutnya you kena input lah the value. Okay, berapa banyak you nak buffer counter ni. Okay, and then last kali, okay, offset buff area ke 10 kali. So buff area tu ada 10 ni lah, 10 location. Okay, and put into SI. Okay, SI equals to address of the first byte of string. Okay, kita ada macro. Okay, what is a macro? Okay, tadi kita dah finish with the interrupt. Okay, there are applications in an assembly language program where a group of instructions perform a task used repeatedly. Okay, so it does not make sense to rewrite them every time. Okay, so tak okay lah kalau kita type the same code every time. Okay, sebab macam before this, kita nak kecilkan program, okay, kita boleh gunakan loop. Alright, so kita tak payah nak buat repetition of the code tu. Okay, so ada juga okay, application in the assembly language program where a group of instructions perform a task used repeatedly. So maksudnya sekarang ada satu task ni yang memang boleh digunakan berulang kali. So dia tak make sense lah untuk kita tulis dia banyak kali. Okay, so inilah kegunaan macro. Okay, macro allows the programmer to write the task once and only and invoke it whenever is needed. Okay, so macam loop tadi kita kena follow, okay, sequence. Patah balik. Ini macro ni is like a function. Okay, it's like a function. So macam you nak buat tambah, so you ada function add kan. Okay, dia akan buatlah tambah bila you type the add. So macro ni macam tu. So dia ada word dia yang you boleh gunakan. Okay, you nak buat apa? Okay, I want to do the multiplication. So for example, so that's example is like a macro. Okay, tapi yang ni task yang lagi ni lah, yang maybe can be more advanced than that. Okay, so macros ni boleh reduce time to write code and reduce possibility of error. Okay, so yelah, kalau lah kita gunakan kita type lagi, kita nak buat function tu, kita type lagi sekali, so dia akan membuatkan kita terdedah kepada error lah. Alright, so kalau kita type satu je and then kita just panggil dia beberapa kali, so bila ada error kita just refer balik lah kepada main code tadi. Right? Okay, every macro definition must have 3 parts. Okay, so name macro, dummy 1, dummy 2 up to dummy n. Okay, and macro. So dia kena initialize and also kena end. Okay, so dia ada tengah-tengah lah. Okay, tengah-tengah. So the first part, okay, and then the end part, and then yang tengah-tengah tu the value within the macro. Okay, the macro directive indicates that the beginning of the macro definition, okay, and M directive signals the end. Okay, in between is the body of the macro. Okay, so in between tadi ada body of the macro. The name must be unique and must follow assembly language naming conventions. Okay, dummies are names, parameters, or registers that are mentioned in the body of the macro. Okay, the macro can be invoked or called by its name and appropriate values substituted for dummy parameters. Okay, a macro for displaying a string of data using the widely used function 09 of interrupt 21. Okay, so you nak pakai macro ni, you kena pakai function 09 dekat interrupt 21 ni. Okay, the string macro data 1, Okay, so maksudnya you nak makrokan data 1 tu, okay, move, okay, AH09, okay, move SDX, okay, offset data 1 and interrupt 21 and macro. So dekat body tu you kena state. So bila you write the macro, so dekat body tu you kena state that move AH09 tu, okay, and then dengan interrupt 21 you nak buat any task. Okay. Okay, in the following code segment, the macro can be invoked by its name with the user's actual data. Okay. Instruction, okay, string message 1 invokes the macro. Okay, so ini invokes the macro. Message db, what is your name? Okay, and then string tadi, okay, dia akan invoke the macro lah. Okay, apa dia buat tadi? Yang ni tadi. Okay. So dia akan masukkan data 1 ni dalam dx. Okay. So itu yang dia buat. The assembler expands the micro providing the following code in the list file, okay, .lst, okay, move AH09, okay, yang ni lah. So dia akan keluar lah dengan ni, yang tadi lah, yang previous slide tadi. Okay, sebab itu yang kita initialize. Okay, the number 1 indicates the code is from the macro. Okay, earlier versions of MASM, okay, use a plus sign. Okay, kalau sebelum tu dia pakai plus sign, so sekarang dia dah pakai ones. Okay, sign dia jadi 1, 1, 1 and 1. Okay, there are two types of comments in the macro, listable and non-listable. Okay, comments preceded by one semicolon, okay, one semicolon will show up in the list file, okay, when the program is assembled. Okay, so those preceded by a double semicolon will not. Okay, so you nak letak comment, so you just put one semicolon je lah. Kalau double semicolon tak muncul lah sebab you dah tutup 2 kali. Right? Okay, 3 directives designed to make programs that use macros more readable, okay, affecting the list file, okay, with no effect on the object of exe file. Okay, ada lagi apa ni, file lain, okay, lal list all, okay, will list all instructions comments preceded by a single semicolon, okay, in the list file, okay, and also suppress all, okay, list all dengan suppress all, okay, suppress all suppresses the listing of the macro body and the comments, okay. This is used to make the list file shorter and easier to read. It will not eliminate any opcode from the object file. And then one more, we have as all, okay, executable all is used to list only the part of the macro that generates opcodes. Okay, the default using listing directive. Okay, so if a macro is expandable more than once, then there is a label in the label field of the body of the macro. So this labels must be declared as a local. Okay, so kalau katakan you gunakan macro banyak kali, right, tak gunakan sekali je, okay, and there is a label in the label field of the body of the macro, okay, maksudnya kalau ada label dalam label field tu, okay, within that body of the macro, so body tadi replace macro kan, you define db semua, macro bla bla bla, and then tengah-tengah tu body, so yang you bawah tu n m, so n macro, so tengah-tengah tu body tadi, okay, kat body tadi you kena bila ada label, okay, bila ada label kat situ, okay, the label field of the body of the macro, this label must be declared as local, so you kena declare that one sebagai local, okay. Otherwise an assembler error would be generated when the same label was encountered in 2 or more places. Okay, rules which must be observed in the macro body. Okay, first, all labels in the label field must be declared local. Okay, and the local directives must be right after the macro directive. Okay, so ni rule dia lah. Okay, and then the local directive can be used to declare all names and labels at once. Okay, local, name 1, name 2, and name 3. Okay, kita look at one example. Okay, in example 47, okay, the back label is defined as local right after the macro directive. Okay, write a macro that multiplies 2 words, okay, by repeated addition. Okay, and then save the result. Okay, so the following macro can be expanded as often as desired in the same program. Okay, since the label back has been declared as local. Okay, so kita cara dia, dia nak micro that multiplies 2 words, okay, by repeated addition and then save the result. Okay, so macam mana kita nak buat? Okay, so macam tadi, dia dah define local tu dekat apa ni, label back. Okay, so multiply macro value 1, value 2 result. Okay, dah ada macro kat situ. Okay, so colon, okay, semicolon, okay, and then double semicolon. Dekat situ this macro computes result, okay, value 1 times value 2, okay, by repeated addition. Okay. Value 1 and value 2 are word operands, result in double word. Okay, baru you masuk you punya real code. Okay, move, okay, value 1 into bx, move value 2 into cx, okay, and then clear ax, okay, you sub, okay, move, okay, ax into dx, okay, so clear ax, so ax 0, so ax tu masuk dalam dx, so dx pun 0. Okay, and then mula you punya loop, okay, add bx to ax, okay, value 1 masuk jadi dekat ax, okay, add carries if there is 1. Okay, so dia akan jadi carry lah. Okay, if ada 1 kat situ, alright, adc kena add, add to carry, okay, dx, okay, and then loop back, okay, continues until cx 0. Okay, so dia akan loop lah, dia akan loop, okay, back, continue until cx 0. So dia akan follow, patah balik ke the back, okay, loop, okay, until cx jadi 0. Okay, move result, okay, save in the low word, okay, move result plus 2 dx, okay, save the high word, okay, and macro. Okay, so semua ni dibuat dalam macro. Okay, so you should be able to notice, okay, the difference of macro, okay, when you use macro and also the normal code. Okay, okay, and then kita ada juga the include directives, okay, which allows a programmer to write macros and then save them in a file and later bring them into any file. Okay, this is used to bring this file into the .asm file to allow the program to can call any of the macros as needed. Okay, so you will refer to that program lah, alright. So it is in the book. I will share you shortly, okay, the book, okay. I think I already shared that with you early of the semester, so you can refer that as well, if I'm not mistaken, but I will share it again. Okay. Okay, so we already finished with the chapter of interrupt, okay, and also the macro. Okay, ada sebarang soalan? Tak ada soalan, so how about we take a break for 10 minutes. Alright, we will continue around 11:10. Okay, with the next chapter.
Okay, Doctor.
Okay. See you.
Heart beats fast, colors and promises. How to be brave? How can I love when I'm afraid to fall? But watching you stand alone, all of my doubt suddenly goes away somehow. One step closer. I have died every day waiting for you, darling. Don't be afraid. I have loved you for 1,000 years. I love you for 1,000 more. Time stands still, beauty in ocean
Okay, welcome back everyone. Okay. Okay, so tadi kita dah dalam chapter interrupt 10 and interrupt 21. Okay, and also we learn a little bit about macro. So macro tu dalam interrupt 21 lah. Okay. Now we want to look into the keyboard and mouse programming. Okay. So yang ni dia gunakan interrupt juga. Okay. But it will be on interrupt 16. Okay. Interrupt 16 untuk keyboard programming. Okay, and interrupt 33 untuk mouse programming. Okay, so we will discuss about that. Okay, so how we utilize interrupt 16 and also interrupt 33. Okay, so in our keyboard, original keyboard, we have 83 keys. Okay, so kalau you pakai yang default lah, you pakai standard. Okay, in 3 major groupings. Okay, first the standard typewriter keys. Okay, 10 function keys, so you ada F1 sampai F10, okay, and 15 keypad. Okay. Okay, in later years, 101 key enhanced keyboards have become popular. Okay, so each key is associated with a scan code. Okay, so dia ada scan code lah. Okay, setiap untuk setiap key yang ada dalam you punya keyboard. Okay, so you boleh refer. Okay, so you boleh refer this scan code ni in your textbook lah, right? The textbook I just shared in the WhatsApp group. Okay, kita tengok kepada interrupt 16, okay, keyboard programming. Okay, the same tadi apa perbezaan dia? Tadi kita tengok dari segi kita nak tengok apa yang berlaku dekat display. Kita input daripada keyboard. So itu interrupt 21. Okay. So apa beza dia dengan interrupt 16? Okay. Kita tengok based on keyboard programming. Okay, maksudnya kita nak programkan keyboard tu. Okay. The same scan code is used for a given lowercase letter and its capital and all keys with dual labels. Okay. The keyboard shift status byte distinguishes the keys. Okay. Some interrupt 16 function calls provide the status byte in AL. Okay. So dia akan provide the status punya tu dekat AL. Okay, ada yang dekat AH sebelum ni kan. So now dekat AL. Okay. For the keyboard motherboard, interaction IBM has provided interrupt 16. Okay, when a key is pressed, okay, the OS stores its scan code, okay, in memory location called a keyboard buffer, okay, located in the BIOS data area. Okay. Alright, so apa ni? Okay, tengok dekat situ table 5.4, okay, the keyboard status bytes, okay. Okay, bit 0 until 7, okay, dia punya mask code dia macam tu lah, 0 OR, okay. If okay, if right key, right shift, okay, right shift press, okay. So maksudnya right shift, you tengok dekat you punya keyboard ada shift kan, shift key. So dia shift tu dia ada sebelah kiri dengan sebelah kanan. Alright. So right shift, dia punya bit pada bit 0. Okay. Contoh you ada register 8 bit, okay. So you boleh letak register from bit 0 up to 7 lah. Okay. So kita tengok dari segi ini yang bukan standard. Okay, ini yang bukan standard sebab dia ada shift key, right, control, okay, alternate, okay, scroll lock, num lock, okay, caps lock, insert, okay. So ni semua dia akan ni lah dia akan distinguish, okay, based on dia punya mask code, okay, mask code yang berbeza-beza ni. Okay, so ini dia punya ni lah, okay, right shift, okay, left shift. Beza dia yang ini E dengan D, okay, E dengan D, okay, and then control B, okay, alternate 7, okay, and then okay, ini yang control shift, control dengan alternate. Okay, bila melibatkan scroll lock, okay, scroll lock you tengok dekat ada home kat situ, okay, scroll lock, num lock, okay, so dekat area sebelah keypad tu, alright, sebelah keypad tu, okay, yang itu, so perbezaan dia, so dia akan mask code dia akan initial dia akan bertukar lah. So ini jadi E, okay, EF, okay, num lock, DF, okay, and caps lock, okay, bila caps lock toggle, okay, caps lock ni sebelah sini pula, okay, sebelah atas shift tu, okay, so B, BF, okay, and insert. Insert you patah balik dekat area tengah-tengah tu, between the main keyboard area dengan keypad, okay, 7F. Okay, so itulah perbezaan dia, alright. Okay, for a program to run tasks continuously while checking for a key press requires use of interrupt 16. Okay, so a BIOS interrupt used exclusively for the keyboard. Okay, maksudnya dia nak tengok sama ada satu key tu ditekan ataupun tak pada keyboard. Okay, maksudnya dia akan tengoklah kalau you tekan A, B, okay, USA, okay, you tekan USA, so dia akan check. Okay, check a key press use interrupt 16 function AH01. Okay, so move AH0, okay, get key press apa yang ditekan, okay, interrupt 16, okay. If ZF0 there is a key press, if ZF1 there is no key press. Okay, itu beza dia. Okay, kalau you punya zero flag, okay, you punya zero flag is 0, maksudnya ada key press lah, okay, so dia activate, dia punya dia tak flag tu tak 0 lah, okay. Kalau tak ada apa-apa, okay, maksudnya flag tu 0, okay, so dia tak ada key yang di press. Okay, so this function does not wait for the user to press a key. Okay, it simply checks if there is a key press. Okay, so maksudnya dia akan check lah. Ini untuk check saja sama ada satu key ditekan ataupun tak. If a character is available, it returns the scan code in AH and the ASCII code in the AL. Okay. Okay, this program, okay, program 5.1 sends the ASCII bell character 07, okay, hex to the screen continuously. Okay, so kita tengok so program ni to stop the bell sound, press any key. Okay, so maksudnya dia nak detect key press lah. Okay, maksudnya kalau you press apa-apa key, bell tu akan stop sound. Okay, so apa cara nak kena buat? So main procedure, okay, move, okay, macam biasa yang atas tu you initialize, okay, untuk display the message, okay, alias data AX, okay, move AX to DS, move 09 to AH, right, offset message into the DX, okay, interrupt 21. Okay, yang tadi sebab interrupt 21 ni sebab you nak display the message. Okay, apa-apa yang menyebabkan display menyebabkan interrupt 10 and also interrupt 21. Okay, So itu dah settle, you nak display the message. Alright, and then okay, now comes to the ni lah, the real program untuk code tu. Alright. Okay, sending move AH02, sending to monitor a single character. Okay, and then send out the bell character. Okay, 07, move DL 07, okay, interrupt 21. Okay, and then move AH01, okay, dia akan check key press. Okay, ada sama ada key di press ataupun tak. Interrupt 21. Okay, and then di check. Okay, jump 0 again. Okay, maksudnya kalau dia jumpa is 0, maksudnya dia punya ni 0, maksudnya 0 flag lah. Okay, 0 flag, maksudnya 0 flag tak di toggle lah, di toggle. 0 flag di toggle, maksudnya 0 flag tu equals to 1. Okay, dia akan loop lagi sebab tak ada key press. Okay, tak ada key press. Okay, so if no key press, then stay in the loop. So dia akan loop until you dicheck. Okay, dia punya ZF punya flag tu dia jadi 0. Okay, ZF equals to 0, then dia akan exit the loop. So baru dia beritahu, okay, bila dah exit tu, nampak move AH 4C, okay, if any key press go back to DOS. Okay, so dia akan stop dekat situ. Okay, interrupt 21, okay, end program. So dia akan exit terus lah program bila ada key press. Selagi tak ada key press, this program akan keep looping. Okay. Okay, tadi kita tengok je apa-apa key yang di press. Tapi macam mana kita nak tahu specific key yang di press tu? Okay. Okay, so kita nak tahu, kita kena buat macam ni. Okay. Interrupt 16 AH0 determines the key press. Okay. This function must be used immediately after AH01. Okay. Okay, move AH0, get the key press, so dia akan tahu key apa yang di press and interrupt 16. Okay. AH0 doesn't return until a key is pressed. Okay. AH1, it comes back whether or not a key has been press. Okay, so itu beza dia. So dia akan wait lah, alright. AH0 dia akan wait until a key is pressed. So selagi tak ada key tak press, dia tak akan jalankan lah that program. Okay, AH1 comes out whether not a key has been pressed. Okay, maksudnya ini tak kisah. Kalau AH dah jadi 01, dia akan ni lah, dia akan comes back juga. Alright, dia akan comes back sama ada key tu di press ataupun tak di press. Okay, AL, okay, tadi AH. Alright, AL contains the ASCII character of the press key. Okay, the scan key is in AH. Okay, for characters such as F1 to F10, okay, F1 to F10 dalam punya keyboard, for which there is no ASCII code, okay, the scan code is in AH and AL. Okay, AH and AL 0. Okay, thus if AL 0, okay, a special function key was pressed. So dia boleh detect lah, kalau dia tengok AL tu 0, okay, maksudnya F1 lah, F1 antara F1 hingga F10 tu di press. Okay. Alright, so tadi kita expand lagi program tadi. Okay, which key is pressed. Okay, kita nak tengok which key is pressed. Okay, to stop the bell sound, press Q, capital Q or small q keys. Okay. So maksudnya sekarang kalau dia tak spesifik, kalau dia tak spesifik, dia tekan je A ke B ke C ke, right, D ke, so dia takkan stop. Okay, sebab sekarang program ni dah spesifikkan, alright, you kena toggle Q je, Q key je dalam you punya keyboard, baru dia akan stop. Okay. Okay, so macam mana nak buat? Alright, beza dia tadi, okay, yang atas sama, tak ada masalah. Okay, yang ini sama. Okay, yang ni pun sama. Alright, sebab yang ni you send out the bell character tadi. Okay, interrupt 21. Okay, move AH01. Okay, dia dekat sini. Right, tengok ah. Dia move AH01, check for key, press interrupt 16. Okay, jump 0 again. Okay, first sama. Kat sini sama lagi. Alright, macam tadi. Okay, sebab dia akan, mula dia akan check dulu sama ada key di press ataupun tak. Okay, move AH0. Okay, to get the character. Okay, interrupt 21. Interrupt 16. Okay. Okay, kena gunakan interrupt 16 one more time. Okay, sebab kita nak tahu karakter apa yang di type. Okay, compare CMP ALQ. Okay, sama ada capital Q ataupun tak. Jump, exit. Okay, kalau yes, maksudnya kalau compare ni equal, maksudnya equal. Jump equal. Okay, maksudnya AL tu you check is ALQ and then sama dengan Q. Right, if yes, exit. Okay, dia akan pergi ke exit lah, go back to DOS. Okay, maksudnya dia akan stop. Okay, one more, di capital. Okay, dia tengok yang small q juga. Okay, compare AL, small q, JE, exit juga. Okay, and jump again. Okay, no, maksudnya jump again ni, dia akan patah balik ke atas. Sebab kalau salah, maksudnya tak sama dengan semua ni, dia akan patah balik ke atas lah. Okay, dia akan patah balik ke atas. So dia akan keep looping and keep looping. Right? So ni dia detect kalau Q or capital Q or small q depressed, so dia akan exit the program. Okay. So itu cara you nak tahulah key apa yang di press. Okay, so other than that, apa lagi function interrupt 16 ni? Okay. So tadi AH01 dah tahu kan? Okay, dah tahu key di press tu tak? Okay, AH0 key apa yang di press? Okay, and then now AH10. Okay, read a character. Okay, the same as AH0. Okay, except that it also accepts the additional keys on the IBM extended keyboard. Okay, so maksudnya dia ni lah. Okay, dia accept additional key on the keyboard tadi, right? So dia akan read the character on the keyboard. Okay, ada lagi AH11. Okay, find if character is available. Alright, the same as AH1, right? AH1, okay, dia akan tahu kan karakter apa. Okay, so beza kat sini, dia akan find daripada karakter tadi yang kita type tadi, if a character is available. Okay, except that it also accepts the additional keys on the IBM extended keyboard. Okay. Alright, so itu interrupt 16. Okay, you ada 0, 1, 0, 0, 0, 0, 0, 1, 1, 0 and 1, 1. Okay. Alright, kita tengok pada interrupt 33. Okay, interrupt 33 untuk detect a presence of a mouse. Okay, so beza sikit, interrupt 33 ni, okay, dia bukan part of the BIOS or DOS, but dulu interrupt 33 dia tak dulu tak mouse tu tak disupport pada BIOS lah. Okay, or DOS. Okay, tapi sekarang nowadays BIOS dah boleh support. Okay, so sebab tu pada waktu tu dia punya interrupt 33 ni is not part of the BIOS or DOS. Okay, interrupt 33 is part of the mouse driver software installed when the PC is booted. Okay, so the first task of any interrupt 33 program should be to verify the presence of a mouse and the number of buttons it supports. Okay, using interrupt 33 function AX equals to 0. Okay, so first interrupt 33 dia akan check. Okay, dia akan check whether a mouse is present or not, and then the number of buttons on the mouse. Okay, so kalau you ada dua lah. Alright, if you have 3 buttons, then it show you the 3 buttons. Okay, on return from interrupt 33, okay, if AX0, no mouse is supported. Okay, if AX equals to FF, the mouse is supported and the number of mouse buttons will be contained in register BX. So dia akan simpan dekat register BX. So dia punya tu kalau tak ada AX saja 0, kalau ada okay, dia akan jadi FFFF. Okay, the mouse is supported and the number of mouse button will be contained in the register BX. So dia akan simpan information of number of button of mouse dalam register BX. Okay, although most mice have 2 buttons, right and left, and there are some with the middle buttons as well. Okay, so for example, okay, move AX 0, okay, interrupt 33. Okay, mouse initialization option tadi. Okay, move AX 0, okay, compare, okay, AX dengan 0. Okay, so maksudnya kalaulah ada mouse to present, kalau mouse to present, of course lah apa ni akan ada ni lah, akan ada continuity of the program. Okay, so the check, okay, compare AX is 0. Alright, so 0 AX. Okay, so jump equal exit. Okay, jump equal, kalau equal maksudnya AX 0 and disama dengan 0. Okay, maksudnya tak ada mouse lah. Alright, sebab dia initialisasi dekat AX 0. Alright, so AX tak berubah. So kalau berubah dia akan jadi 1. So 1 dia ni lah. So dia akan follow apa yang ke bawah ni. Okay, so dia tak akan pergi kepada exit. Exit ni dia akan exit the DOS. Right? Okay, and then so dia akan check button. Okay, kalau ada dia akan check button. Mouse is there, save number of buttons. Okay, dia akan masuk pada BX. Okay, move M button, okay, BX. Okay, button ni akan save kat BX and BX you put lah dalam mana-mana another variable. Okay, another register. Okay, in interrupt 21 and interrupt 10, register AH is used to select functions, not in case of interrupt 33. Okay, macam tadi kan, kita specify AH berapa? 01, 0A, 0C apa semua tu. Okay, yang tu kita nak select, kita nak gunakan function apa. Okay, kita nak display the ni ke, nak display the option high resolution ke apa ke, kita gunakan AH. Okay, tapi dekat sini, okay, dekat dalam mouse ni, mouse programming, okay, kita tak samalah. Alright, AL, okay, untuk AL is used to select various functions and AH is set to 0. Okay, okay, that's why this the reason for move AX 0 tadi yang atas tu. Okay, okay, jangan lupa letak H kat belakang. Okay, interrupt open saya set interrupt 31, interrupt 33, interrupt 10. Okay, so make sure that you always put H at the back. Okay, if you mention that as hex. Okay, so because if absent, the compiler assumes that it is decimal and executes interrupt 21 H. Alright, because 33 decimal, okay, 33 decimal sama dengan 21 H. Okay, maksudnya 33 base 10 sama dengan 21 kalau base 16 or hex. Okay, the mouse pointer, okay, or cursor is the pointer on the screen indicating where the mouse is pointing at a given time. Okay, so macam saya punya mouse sekarang kat mana? Okay, no, okay, in the middle of the screen, okay, at the edge of the screen. Okay, so you boleh tahulah. Okay, if in graphics mode it is an arrow, in text mode it is a flashing block. Okay, so dia akan flash block lah, macam bila yang nak tulis kat Word tu kan, dia akan tukar lah dekat text mode. Okay, graphic mode macam ni lah. Okay, dia ada dalam bentuk arrow. As the mouse is moved, okay, the mouse cursor is moved. Okay, while movement of the mouse is measured in inches, okay, or centimeters, movement of the mouse cursor on the screen is measured in units called mic keys. Okay, mic keys. Okay, so the mic keys unit indicates mouse sensitivity. A mouse that can move the cursor 200 units for every inch, okay, of mouse movement has a sensitivity of 200 mic keys. Okay, so katakan saya gerak satu inch, okay, 1 inci daripada sini kepada sini, dia ada 200 unit di dalam tu. 200 unit, dia maksudnya dia sensitif lah, alright, sebab dia boleh kecilkan lagi, alright. Okay, in this case, 1 might represent 1/200 of an inch on the screen. Okay, maksudnya 1 mic key tu sama dengan 1/200. So 1 inch tu bahagi dengan 200. Okay, some might have a sensitivity of 400 mic keys in contrast to the commonly used 200 mic keys. So dia ada yang 400 juga pun ada. Alright. The A@01 function, okay, of the interrupt 33 is used to display the mouse cursor. Okay, A01 interrupt 33, dia akan display the mouse cursor. If the video mode is graphic, the mouse arrow is visible. Okay, if the video mode is text, a rectangular block, okay, representing the mouse cursor becomes visible. So dia akan block hitam lah. Okay, block hitam putih dia boleh klik. Okay, so the mouse of the mouse cursor block is the opposite of the background color in order to be visible. Okay, so dia kena kontra lah color dia. Dia tak boleh sama. Kalau sama tak nampak lah dia blinking ke tak blinking ke. Right. Okay, to hide the mouse cursor after making it visible, execute option A@02 of interrupt 33. So you boleh hilangkan balik, okay, cursor mouse tu, you gunakan AH02. Okay, and then interrupt 33. Okay, when the video mode is set to the text mode, okay, the mouse will automatically adopt the same resolution of 640 times 200 for its horizontal and vertical coordinates. Okay. Okay, dia akan gunakan sama je resolution kalau you punya video or text mode. Okay, when a program gets the mouse cursor position, okay, values are provided in pixels and must be divided by 8. Okay, to get position in terms of character location 0 to 79 and 0 to 24 on the screen. Okay, so ini dia punya ni lah mouse resolution compare tu dengan video resolution yang available. Okay, so dia akan follow lah, dia akan follow video resolution tu. So kalau video resolution 640x200, mouse resolution pun sama. Okay, cuma and then sama juga bila dia berubah akan berubah lah. Okay, tapi you nak pilih tu, you tengok lah dia punya video mode akan berbeza-beza lah, sebab ini akan toggle the video resolution ni. Alright. Okay. Alright, yang ni untuk text, yang ni untuk grafik. Okay, sama je, and then character full screen pun sama, except when you choose different video mode lah. Okay, kat bawah ni. So it will be different after that. Okay, option AX03 of interrupt 33 gets the current position of the mouse cursor. Okay, on return, the X and Y coordinates are in registers. Okay, CX and DX. So you nak dapatkan current position of the mouse kat mana? Okay, nak tahu kat mana? Macam my position of the mouse kat mana? Okay, dia akan bagi you punya X and Y coordinates lah. Alright. So dia akan simpan yang horizontal tu, yang X tu dalam CX, okay, and DX akan simpan yang Y coordinate, okay, yang vertical. Okay. So BX contains the button status, okay, 1 if down, 0 if up. Okay. So maksudnya kalau button tu down, ditekan, alright, dia akan jadi 1. Kalau up ke atas, tak boleh ditekan, akan jadi 0 lah. Okay, BX. And then dia akan refer to D0, D1 and D2. Okay. So D0, D1 and D2 akan menunjukkan status. Okay, menunjukkan status butang mana yang ditekan. Okay. Okay, the cursor position is given in pixels. Okay, to get the mouse cursor character position, divide the horizontal and vertical values of CX and DX by 8. Okay. Okay, so you can refer to the example. Okay, program 5.3 and 5.4 in the textbook. Okay, kita ada lagi banyak sikit ni dia punya mouse position ni. Kita ada interrupt 33 option AX04. Okay, allows a program to set the mouse pointer to a new location anywhere on the screen. Okay, so kita boleh set dia nak muncul kat mana, dekat ujung edge ke, kat tengah, okay, and the other edge, right, or the bottom, okay, or the bottom left, okay, boleh kat mana-mana pun tak kisah, asalkan you gunakan function AX04. So you will determine that. Okay. Coordinates for the new location must be placed in CX for the horizontal, okay, and DX for the vertical. The values must be in pixels, okay, in the range of 0 to 639 and 0 to 199 for 640 times 200 resolution. Okay. Okay, interrupt 33 options AX05 is used to get information about the specific button pressed since the last call to this function. Okay. Tadi 04, okay, now 05. So dia banyak sikit macam I said. So ada 01, 00, 01, 02, 03, okay, 04, 05. Okay. So yang ni kita gunakan untuk tahu button mana yang ditekan tu. Okay. So BX0 for left button, BX1 for right button, 2 for center button, for return. Okay. AX button status. Okay. So D0 left button, kalau 1, 2, D1, D2, D1, D and D2. So dia akan refer kepada location of your punya ni lah, button mana yang you tekan. Okay, and BX button press count. Okay, and then CX equals to X coordinate of the last button pressed in pixels. Okay, and also for the DX. Okay, you can refer to the example in the book. Okay. Alright, also program 5.5. Okay, digunakan AX05. Okay, tadi AX 05 juga. Okay, sama. So you can refer to the textbook. Okay. It prompts the user to press the left button of a number of times. Okay, when the user is ready to see how many times the button was pressed and any key can be pressed. Okay, so that's it for the chapter of keyboard and mouse programming. Okay. All right, we have last week of the semester. Okay, will be next week. Okay, I need to replace you for 1 more hour. So for the holiday on the last Tuesday, okay, so we will resume that on next Tuesday, and then we will have no normal class on Thursday, the last class of the semester. Okay, by the meantime, okay, maybe there will be a time for me to teach you on the a little bit of programming, okay, using the um, assembly programming, okay, next week, and then we will see that. Okay, okay, Abuza, any question?
No, doktor.
Tak ada.
Tertekan.
Oh, okay, okay. Alright, ada sebarang soalan? Okay, any further information will be given next week as well, okay, regarding your final and so on. Alright, will be given next week. Also, there may be a couple of more assessments, especially the quiz as well. Okay, next week. Okay. Alright, so that's it for today. So as usual, please turn on your camera so we can take the picture together. Maknanya tak ada orang pun buka kamera, semua angkat tangan ni. Okay, Hamzah. Alright, thank you. Mana lagi yang lain? Tak ada lah. Okay. Najah, right. Thank you. Alright, so anyway, let me count from 10. Alright. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Alright. Thank you.
Thank you, Doktor.
Okay.
Thank you, Doktor.
Welcome.
Thank you, Doktor.
Thank you, Doktor.
Welcome.
Selamat. Bye, Doktor.
Bye.